Hello, Dave here, and I'm going to walk through a little tutorial on X-rays, and I'm not sure whether I'll use whiteboard or Word or something. Let's try whiteboard. Okay, so one of the first things we need to think about with X-rays is you can kind of think of X-rays as coming from this kind of physics class. Think of it as coming from a fixed point. Kind of like imagine a light bulb that's really, really tiny, and everything spreads out from that light bulb. There's a little more complicated stuff going on inside the machine itself, but for simplicity's sake, you can imagine that there's a tiny, tiny, tiny little speck of light shining downwards. Give this a 3D perspective for moments that will hopefully become clear shortly. So you've got this point source of light, or X-rays, and you've got a rectangular or square flat piece of film some distance away. And in between, at some distance, is going to be our patient, our object, I think the technical word would be in this chapter. And so there's a ratio between the distance between the point the X-rays come from, the focal point, the distance to the object, and the distance to the film. And there's a few other factors we need to consider. One factor is, actually I'll put in here, I'll put focus. Actually, let's see if I've got a text tool that will look a little neater. Here's our focus point. Maybe the word's focal point, I suppose. The focus or the focal point, either way. This blue thing is the object, i.e. the patient, and down at the bottom we have film. And so the X-rays will shine down. Oops. And illuminate our, shine through the patient essentially and expose the film. Where you've got something dense, less X-rays go through and creates a less exposure on the film, less light essentially strikes the film, and then when you go to develop it, the spots that were light become dark and the dark become light. Whole negative film negative process goes on there, but essentially that's the basis of what goes on here. Now, if we increase current up here at our focal point, basically putting more electricity to produce more X-rays, what's going to happen to the film? Although that current is going to cause more X-rays and they're going to spread out, but they're going to spread out across this area. And the unit for area square units. So when we look at how much exposure is happening, as we increase the current, it's going to essentially illuminate the same area with more light. If we move the film further away, the light's going to become less dense, shining on that film. Or if we move the patient relative to the film, it's going to change the magnification, etc. So there's a few factors at play here. One of them is original current over original focus to film distance squared. I'm going to put this little symbol here is called the caret, a little upward pointy thing. Shift 6 on your keyboard, but anytime I type that, it means to the power of 2 or squared, if there's a 2 following it. Did I spell original right? No, I didn't. So we've got this ratio, which happens to be proportional to new current. Current is measured in milliamps, divided by our new focus to film distance, also squared. And the nice thing about this is current is pretty much always measured in milliamps for our purposes. The nice thing about this equation is whatever we measure distance in, as long as we're consistent, it doesn't matter. I could put inches on the left, so measure all my distances in inches, and have distances on the right in inches. The equation's going to work nicely. The units are the same, things work nicely. If I measured things in metric on the left in centimeters, then things on the right also have to be in centimeters. You don't have to convert back and forth. If the question asks in centimeters and expects an answer in centimeters, don't have to switch to inches and back, don't have to switch to meters and back. Just keep the same units all the way through, as long as it's consistent. If the question asks you in meters and expects the answer in centimeters or inches or some other, then yeah, you might need to convert. But typically we're not testing your conversion abilities, we're testing your ability to use the equation with the proper units or the typical units to begin with. Another way we can get more light to shine on the film, and more contrast, I suppose, if certain spots of the patient are more blocking, or hesitate to call a patient dense, but density of bone, for example, is different than that of muscle, etc. So if we increase the amount of time the X-rays are produced, that will increase the exposure. So our next equation is original time divided by original distance equal to new time divided by new distance. It is worth keeping in mind, sometimes in your calculator you might need to put brackets in like this, so that you do squaring before you do division. Just something to be careful of with your calculator. Sometimes just pay attention to order of operations. Your calculator is probably pretty sensitive to order of operations, and if you're not thinking the same way the calculator does, it could lead you astray. Best to show your work on a piece of scrap and scan it or send it in to me, hard copy if need be, in order to justify part marks. And then I can also correct and say, okay, here's where I think I found the error. It was in order of operations rather than understanding a concept. And finally, if I increase the original milliamps, I would also have to increase my new milliamps. If I increase my original duration, it's going to increase the exposure. and therefore I need to increase time as well. So if milliamps goes up on the left, milliamps has to go up on the right. Or if milliamps goes up on the left, some has to go up. Maybe we could increase time instead. If we want to keep the current the same, we can change the time. Your textbook kind of rearranges this though, and they write this. Of course, if we look at the equation, we can divide both sides by new time, and we can divide both equations by original time. So this equation is actually just a variation of the previous equation. If you're trying to remember things, you might find this one easier. Just think intuitively, what's going to increase my exposure? Whatever's going to increase the exposure goes on the top. Whatever would decrease in exposure is going to go on the bottom. So that's how I would remember it, but whatever works best for you.